Today we're going to look at a pretty difficult derivative from first principles question. This is a question that I came across in one of my mock exams a couple of years ago at university. It's a pretty difficult question. I wasn't able to find a solution at the time, but I found one now and I think it's pretty interesting to go through. So I just thought I'd make a quick video about it. So there's a couple of things that you're going to need to know before you can follow along with the solution, and that is obviously derivatives from first principles. The second thing you're going to need to know is basic trigonometric formulae, for example the cos addition formulae or the specific case of the cos subtraction formula. There's also approximations to cos x and sin x that you can derive using calculus and geometry that we're going to be using. And then lastly there's the binomial expansion, which also follows from Taylor series, which basically takes this form to first order. So let's get on with the question. Obviously the first step to taking the derivative from first principles is to apply the formula above. So we're going to need f of x plus h, which is 1 over x plus h times cos 1 over x plus h, and then we're subtracting f of x, which is 1 over x times cos of 1 over x. And then of course we have to divide by h. So in order for this to be a form that we can comfortably take the limit in, we're going to have to rearrange the fraction a little bit. And we're going to do it using the binomial approximation. So if you saw the last video on index rules, you'll know that 1 over x plus h can be written as x plus h to the power of minus 1. In order to get this in the form 1 plus some small quantity, we need to take out a factor of x, like so. Obviously this is all to the power of minus 1. Then we can use an index rule to distribute the power. And then we can simply apply this formula here to get an approximate formula that will be more useful for taking the limit. So for convenience we're just going to expand this as 1 over x minus h over x squared. So this is what we're going to plug into the formula above. So continuing with this, we're going to have the limit as h goes to 0 as before. This time we just plug in 1 over x minus h over x squared multiplied by cos, same thing, 1 over x minus h over x squared, and we're subtracting the original function. There we go. So now we're going to apply the cos formula, also listed above. We're basically just going to do a bunch of expansions here before we can start simplifying. So we'll leave this coefficient as it is. And then expanding it, we have cos 1 over x times cos h over x squared plus sine 1 over x times sine h over x squared. And then the rest, which is unchanged. So now, like I said, we're just going to keep expanding. We need to multiply this out, like that. So writing out all these terms, we have 1 over x cos 1 over x cos h over x squared. That's this term. Then we have 1 over x times sine 1 over x sine h over x squared. That's this term. Then we have minus h over x squared cos 1 over x squared cos h over x squared. I'll see if I can fit this all in one line. And then the last term is h over x squared sine 1 over x squared sine h over x squared. And of course I can't fit it all in one line because I have this term on the end. But there we go. So that's the whole thing. And then obviously this is all being divided by h. So now it's all expanded, we're going to try and regroup some of the terms. So let's write the limit. Let's start with terms containing 1 over x cos 1 over x, and I will colour code it to make it easier to follow. This is the term we're concerned with. This is another term that has 1 over x cos 1 over x. So if we write this out the front, basically factoring it, then in the brackets we're going to have cos h over x squared, and then obviously the coefficient of this is just 1. You can see that if you multiply this out, you'll get the original terms, so that's good. Now let's consider the sine terms. So this will be this term and this term. Well, we can factor out sine 1 over x, sine h over x squared, that's common to both those terms. So let's do that. Sine 1 over x, sine h over x squared. Oops. And then in the brackets, so coefficient of this is 1 over x, and the coefficient of the other one is h over x squared. So if you multiply that out, you'll get the original terms, that's all good. And lastly, we have this term on the end, h over x squared cos 1 over x cos h over x squared. So that should be all the terms dealt with for now. And we divide by h. So next step, we want to use the approximate formulas for cos and sine when the arguments are small. So here we have arguments of h over x squared. You're always going to be able to choose an h such that it is smaller than x squared, which means that these terms can always be considered small. So we can always use the expansion. So let's write it out. We have 1 over x cos 1 over x. This can be rewritten as 1 minus h over x squared over 2, and then we subtract 1. And then this sign here can be written as h over x squared, approximately, obviously. And then that's left unchanged. Now, this last term on the end, we're just going to leave it as it is for now, but you can see that once we divide by the h, we can immediately take the limit, so we're not going to worry about that. Okay, so let's have a look at this first term. The 1's cancel out, left with h squared over x to the 4, and a 2 on the denominator as well. So let's just go ahead and write that. So it's 1 over x cos 1 over x, h squared over 2x to the 4. Let's write that by itself over h, because here we can already start dividing by h. This term is by itself, has an h in it, so we can just take the h out. So I have sine 1 over x, 1 over x squared, 1 over x, not squared, sorry, just 1 over x minus h over x squared. And same with this term here. You can just divide by h, leaving us with this term. So these two terms, we're ready to take the limit. This term here, well, if you do divide by h, what you're left with is, we can just write it here, you just get rid of an h, so it becomes, instead of h squared, it just becomes h. Now when the limit as h goes to 0, this is just a coefficient. The rest of it is not dependent on h, so it's just 0. So this term in the limit goes to 0. Now what about these other terms? this is not dependent on h. This is the only part that is. As h goes to 0, this goes to 0. So this in the limit is also equal to 0. And then lastly on the end here, what happens as cos h over x squared, what happens as that goes to 0? Well, you're left with cos 0, and what is that? That's equal to 1. So you're just multiplying this term here by 1 in the limit. So we pretty much have a result. First term, 0. Second term here, we have 1 over x times 1 over x squared, which is 1 over x cubed, times sine 1 over x. And then the last term is just 1 over x squared cos 1 over x. And that's our result. We've taken the derivative from first principles. But how do we know that it's correct? Well, we know how to do derivatives, so we can simply take the derivative of the function. So if we're going to do d by dx of 1 over x cos 1 over x, we can use the product rule and the chain rule in order to see what the result should be. So using the product rule, these are the two terms we multiplied, 1 over x and cos 1 over x. So using the product rule, we apply the derivative to the first term, which is going to be negative 1 over x squared. We multiply it by the term on the right, which is cos 1 over x, so that's left unchanged. And then we leave the term on the left unchanged, and we take the derivative of the right, which is cos 1 over x. Taking the derivative of that. So we see that this term is promising. And applying the derivative to this term, just write this out again, we're going to need to use the chain rule. So the derivative of cos is minus sine. So minus sine of 1 over x. And then the chain rule means that we have to multiply this by the derivative of the inside term, which is minus 1 over x squared. And writing that out and simplifying, these minuses cancel out. The 1 over x squared gives us 1 over x cubed. And then we have sine of 1 over x, which is exactly the result that we got before.